People ask me all the time, how did I learn printed circuit board design? How can I learn like you and be ready for industry and get those industry roles for hardware PCB designers? Well, it was books. Back in 2014, I was the graduate teaching assistant for senior design, and my mentors, who were control system professor and professional PCB designers, they got me on needing to teach Cadence Allegro to the students to design printed circuit boards. Mind you, just like most universities, we never got taught printed circuit board design. So how was I supposed to teach it? Nonetheless, I did it for my job. One of the students recommended this book by Kraig Mitzner. This is the complete PCB design using OrCAD Capture and PCB editor. Now, they recommended the 2009 version. The 2009 version was the latest version that was out, and the 2008. I read through those and they opened my eyes. And there's a chapter in here that is the most important chapter for all of electrical and electronics engineering. This chapter is what opened my eyes to really understanding what EE was all about. So you're going to want to stick around for that part of this book. The reason why this book is so important is because while it's possible to learn printed circuit board design from any tutorials that are out there, I've taken them all. Trust me, they're all good. But what makes this different is it addresses the industry standards. See, when jobs and companies post these jobs, right, the job descriptions, they expect you to know what's inside here, the industry standards. We're talking IPC standards. We're talking design for manufacturing, design for fabrication, assembly, design for cost, design for test. DFX is what it's called. All right. You're going to need to know all that stuff. And those are not addressed most times. You have to read articles, piece things together. What this book does is it puts them all together in a nice little bow and explains things like the JEDEC organization, the JEDEC standards, the IPC standards. A lot of people, when they're getting started into this, they say, oh, I don't know about IPC. What is that? Also designing for assembly, where to place components in comparison to each other, the spacing involved. This is design for assembly, and rules that you would put into your tool for design for assembly tolerances. Now, the tolerances have gotten tighter for some fabricators and assembly houses, but they're pretty much the same, and those are addressed in this book. It also talks about the classes of printed circuit boards. It gives you an overview of how printed circuit boards are fabricated, like with the different layers on the PCB. It even talks about breakout of a plated through hole during the manufacturing and fabrication process. Once you understand the specific problems related to fabricating the PCB, it's then that you have the understanding to design the board with proper intent. Now, this is the most important chapter, and that is chapter 6, all about electromagnetic compatibility, EMI, grounding, and signal integrity. It talks about the capacitances between the planes. It talks about and addresses PCB design for signal integrity and this net and how everything is connected. Ground planes and ground bounce, issues related to noise, distortion, frequency response, electromagnetic interference and crosstalk, magnetic fields and inductive coupling. This is the complete foundation to all of electrical and electronics engineering, because we are in the business of managing and moving the electromagnetic waves and fields, just guiding them through dielectrics. The in-between of your PCB, that epoxy resin, that glass fiber weave, that's a dielectric. It moves at roughly half the speed of light, the electromagnetic waves. Air is another dielectric. Space is another dielectric material. And then it addresses what electromagnetic fields are and how they behave. See, we're going back to the EMI course, right, from the bachelor's. The equations, flux, okay, flux density, and the magnetic coupling, and also it addresses loop inductance, signal reflections on the PCB, and how you have electric fields and capacitive coupling. It addresses everything here, gives you the proper mental models to understand the field. When you understand and design for the field, everything else becomes easy in printed circuit board design. And then, of course, a matter of fabrication and PCB layout and assembly. It even has the equations pulled from your IPC sources. And there's also the PCEA, the Printed Circuit Engineering Association. You're going to want to check them out. They have many of the original authors of the IPC, and also signal reflections. Where does ground bounce come from? Explains the equations, critical length of a trace, PCB layer stack up. Once you understand EMI and signal integrity, then you're ready to understand how many layers I'm supposed to use on the PCB. That's a common question I get all the time. I might address that in another video. Trace width for current carrying capability. Where do you set your trace widths? People ask me that all the time. The distances you're supposed to put your traces to reduce and minimize coupling. You want to keep it under 8% in most or a lot of cases. And using PSpice to simulate these. This is the type of stuff you're supposed to know at Intel. Intel actually asked me one of these questions. They're asked, how would you assess the signal integrity at the schematic level? I say I do it at the schematic level using simulation and a Manhattan distance. I'm telling you, these are the little things you're not going to learn from academia or from the basics. You're going to need to dig into the books. So this is a book that addresses 80 to 90% of your concerns. Now, who is this for? This is for your students, junior engineers. It's a good reference even for senior designers. If you're a Cadence OrCAD user, then this book is for you. If you're an entrepreneur who wants to design your own hardware and just wants to understand what's going on, you need to read this book, because you're not going to be getting any product shipped out successfully without a bunch of headache if you don't understand this chapter 6 in the book. Now, the tool might change, right? If you're using Cadence, Allegro, and OrCAD and whatnot, it'll be a little different in some of the menu items or options. Don't have that as a disqualifier. Even if you don't use that software, the value of this book is gold. You're going to learn everything you need to know, regardless of the software you're using. The JEDEC standards, okay? Design for assembly, design for fabrication, the tolerances, and of course the signal integrity and EMI. So what I've done is I put the link to this book below in the description. It is an affiliate link. I don't get much money from it, maybe a few cents, okay? But click the link below if you want access to this book at no extra cost and you want to help support the channel. And this book is going to give you the majority of what you need if you want to be serious about hardware design and practical implementation as well. Thanks so much for watching this video. Hopefully this has been helpful. This will be the biggest game changer for your PCB design hardware journey. I know it may seem a little old school. That's okay though. Get this book. It will change your life. It did for me. And this is what got my foot in the door to be taken seriously by companies like Apple and at Intel.